Awesome. So my name is Chris Munns. I'm from AWS, and I'm going to talk a little bit here about how AWS uses serverless to build serverless applications, or serverless services, I should say. Awesome day today here, Serverless Days Boston, first event here in the city, which is the turnout and the talks and everything have been incredible. And as we've seen and heard from a lot of people today, serverless is really changing the way that software is being built across the industry. We've heard from a number of companies, a number of practitioners who've been building serverless applications the last couple of years. And while we're only really maybe about 4 years into the existence of serverless as a terminology, as a space, and the technologies defining it, we're still seeing this great impact roll really, really quickly through the industry. And I would say for us at Amazon, it's no different. So we believe very much in dogfooding our own technology. Amazon launched AWS out of kind of seeing how we were building these internal services that made a lot of sense for other companies to use. Fast forward about a decade or so later, and you see what we have now in AWS, the platform. And so question, how does AWS build serverless services using services? Well, we use a compiler, so that's definitely one important thing. All right, but just hope for a little bit more laughter. End of the day, you all want your alcohol. I get it. No, but really, and obviously less time managing servers means more time having fun and laughing, ideally. But no, what I really want to do is talk a little bit more about how Amazon does development. I find that a lot of people don't know this story, but it's very pertinent to kind of the rest of the big picture here. How serverless has changed things, and then lastly, what you could kind of learn from this. So a little bit of history about Amazon and how we're organized, founded in 1994. If you go from 1994 to 2001, we looked like most enterprise organizations still do today. Monolithic teams, monolithic tech stack, a lot of effectively high fences between dev and ops and security and everything else. And so we started looking at ways of how we could change that. And so we kind of famously went through a pretty big shift into kind of 2001 to 2002 into this concept of 2 pizza teams and building microservices. Real quick, can folks in the back hear me okay? I can't tell if this is working right. Cool, thank you. So first, talking about this concept of 2 pizza teams, it's something that we've become pretty famous for in the industry. Really, the idea is that as teams grow in size, you start to find a breakdown in the effectiveness of them. And so a 2 pizza team at Amazon means about 6 to 10 people treated as a somewhat autonomous team that is going out and building some sort of product. And now that product could be an end consumed product. It could be part of a larger whole. There's lots of things that it could be. I don't like to say the phrase that it's a startup within an enterprise. I don't believe that's accurate. But again, these small autonomous teams kind of all moving forward doing their own thing. Full ownership and full accountability and so forth for what they do. And what they build are microservices. And so this Death Star's kind of diagram here is from about circa 2008, 2009. These are all the services that were inside of Amazon. And so the black lines kind of represent the dependency trees across them. And so in the center, you do have things like authentication, authorization, other commonly used and shared services. And so again, this is a decade ago. Where we are now would be an image that would be too hard to represent. It would just look like a giant sphere of points. And again, we've been doing this much longer than pretty much anyone else in the industry. A little more about that, Mylan, who may be a little hard to see in this picture here, is a VP of storage services. She runs S3, spoke at reInvent about how when S3 first launched, and so S3 was the first GA service at AWS. The first actual announced service was actually SQS. But the first GA service was S3, and when we launched it, it had 8 microservices. So already a pretty distributed, kind of broken apart service. If we jump forward to where we were at reInvent this past year in 2018, it's now more than 235 microservices. So again, we have a lot of experience and I would say expertise in building distributed systems, very complicated products in this microservices type of model. But now there's one thing that when we talk about this 2 pizza team model and how they build these microservices and how they operate, and I like to give this concept of the 2 pizza team responsibility Venn diagram. And it's a pretty poor Venn diagram in that the 2 circles really don't overlap that much. Really where we kind of see them kissing is this one little area here where if the product that they're building is a tool, then that's where they care about it. But otherwise, what we basically give our teams and our developers is a fairly fixed box of tools that they then consume and build stuff from. So the 238 microservices that are in S3 today are built pretty much across an entirely standardized stack of tooling. And it goes well past what you see represented in the blue circle here. And again, we want to keep them from having to spend their time finding their own deploy tools and management and monitoring tools and all of that stuff, and just make it really easy for them to focus on what it is that they're trying to accomplish. And so we have some guidelines around these rules. We want them to be very much self-service. We don't want people to have to put in, say, a ticket into a ticketing system to get a virtual server or a database or access to S3 or anything like that. I want these to be as much as possible technology agnostic. So we want to move away from saying, oh, you can only use language X to you can use language XYZ and potentially bring your own. But we want to encourage best practices. So we want to put some smart guardrails in there so that you're not going and putting yourself into a dangerous position. And then lastly, we favor really single-purpose services. How many of you use Jenkins in here? Okay. How many of you can accurately tell me how many plugins you have installed in your Jenkins install? Right, so that many, exactly. So that's an example of a tool where it's not single purpose. It becomes a Swiss Army knife with a blender and a microwave and a flamethrower and a bunch of other things strapped into it. And I actually find that that's very dangerous in a lot of organizations. And so single purpose tools kind of bolted together and then can be used in coordination. And again, what we really want to drive here is this idea that the fixed box of tools is going to give them the best benefit to building their products as quickly as they can. And so we've released a number of things over the years. Back many, many years ago, we had a tool called Apollo. Apollo was used for doing code deployments. So rockets launching code. It's kind of the analogy here. And it had some basic kind of things. It wanted to allow no downtime deployments, make it really easy, and again, remove people having to think about that. And Apollo has been used at massive, massive scale for well over a decade now. There's another service that we came out with in about 2009, so just about 10 years ago, called Pipelines. What's interesting about that time frame is in 2009 was the first time that the word DevOps ever showed up in a presentation. So we were kind of back in the day thinking about CI and CD in a very highly automated way and built this internal tool called Pipelines. Today, Pipelines is used incredibly heavily at Amazon, almost to the point where it's borderline dictated that you need to automate your development process. And so this allows for automation from CI/CD, puts in place standards, allows various controls and logic gates and security gates and stuff to be put in place. And so it gets teams away from having to think about how they're going to go and deploy their code. And now there's a whole lot of other tools that exist. We've got many teams that build all sorts of different tools. Many of them I can't describe publicly, but all sorts of things. If you can think of a tool that you need, Amazon has typically built that tool for themselves. We've also found that continuous delivery leads directly to happier developers. So we do a lot of internal kind of voice of the customer type surveys to understand, are people happy with teams? How does it impact them? And so continuous delivery is a really important part of what we do and how we think about delivering software. Okay. So if we put all those things together, now we have thousands of two-pizza teams, many of them today. And they're building a microservice-based architecture, again, somewhere between 8 and 250-something services in S3, practicing continuous delivery across multiple environments, so dev, staging, prod, and so forth. The number that we have for 2016 is that back then we did 60 million deployments. Now, the 60 million deployments was largely in VMs. Back then, there wasn't a whole lot going on in the container space at AWS. Lambda was still fairly new. And these teams had, again, this fixed set of tools in their toolbox that was really easy for them to work with without starting to go and use some of these more newer cutting edge things. So they were just starting to kind of tiptoe their way out there. So again, 2016, 60 million deployments. It works out to be a deploy more than once every second of the year. It's a lot of deploys. But there's still a lot of things that the teams have to deal with. There's still a lot of things in that green circle that take up their time that isn't just writing their application. They have to think about, again, in the VM-centric world, they have to think about their fleets of servers, the configuration of them, the software installed upon them. Are they meeting the certain security guidelines that they have to? And a lot of this stuff was kind of platform as a service away for them, but there was still a lot of knobs and levers, a lot of flexibility, a lot of responsibility that they had to consume upon themselves. Another thing here, a quick poll. How many of you run in, we'll start with the more than 7. How many of you run in more than 7 regions around the globe on AWS or any cloud provider? A couple, okay. How many of you run in just 2 regions? A bunch. Okay, how many of you run just in 1 region? Okay, great. So the bar for most AWS service teams these days when we launch a new product and it becomes generally available is above 7 regions. And that's operational load. That's cognitive load that they have to take on. If we look at our, well, it's a way brighter slide than I expected it to be, my apologies. If we look at our global infrastructure map, each of the orange circles represents an existing region, and then how many availability zones are inside of that. Green regions are future planned and announced. But if you think about this, each region represents a place where their infrastructure is running, that they have to think about the services, the availability, the monitoring, the logging, all of that stuff. And again, we give them a lot of tools, but there's still a lot of places where things can potentially go boom. And so this cognitive load placed upon them to manage all this infrastructure adds weight. It takes up people hours in a given month period. And so as we grow the infrastructure and as we grow the tasks that these teams are taking on, we're constantly looking at the balance between the operational workload, the development workload, and thinking more and more about how we can shift and keep them from being completely overwhelmed by operational workload. Beyond that, we're looking at all the stuff that was in the green circle before and saying, how can we shift stuff more over to the blue circle? And so you fast forward a couple of years later, or actually now you go back a couple of years, we launch AWS Lambda, and I think almost everyone in this room is now familiar with Lambda and functions as a service and the serverless space and all of that. And this is the benefit of getting to speak last today, is I don't have to say like what serverless is or anything along those lines, which is pretty cool. So let's get real. Let's talk about how this is actually used now at Amazon. I'm going to use a couple of examples. So one thing that we saw very early in the days of Lambda, and I've been at AWS now for just shy of 7 years. I was read in on Lambda before it launched, and then I've been part of the Lambda and serverless organization for a little over 2 years. So I've got some of these stories here firsthand. But what we saw early on was a lot of patterns, a lot of repeatable things that could happen. And again, looking to reduce waste, how do we make repeatable things easy to do without having to completely repeat all of it? And so an example of an architecture, let's say that I have a DynamoDB table, and I want to take the records that have been changed in that DynamoDB table, and I want to do 2 different things to them. I want to make them searchable in Elasticsearch, and then I want to archive them into S3 so that I can do stuff like data warehousing with Athena on top of them. So let's assume that my records go into DynamoDB from some sort of web interface or API interface. I'm then going to have a Lambda function that's invoked off of that. And then what I'm going to do is use SNS to basically allow me to solve those 2 problems, 2 independent workloads. So the first is that I'm going to take the data from SNS and pop it off to an SQS queue, which now could have Lambda tailing it, which could send it into, say, Kinesis Firehose, which could then replicate that data into Elasticsearch. And I'm purposely doing this asynchronously to allow for buffer and potential growth of the traffic without maybe flooding, say, my Elasticsearch service, versus doing it synchronously and having to have this scaled way up to be able to handle it. Similarly, I want to take my data and put it into S3. And so I can again use SQS, again use Lambda, put it into S3. And maybe I need to do something like change the format of it. Maybe it comes in as raw records, CSV or something like that, and I want to change the format into something better for Athena, like Parquet files or something. So pretty straightforward. This is actually a really common basic architectural paradigm for Amazon-based services. But now there's a couple things that are about this. Each one of these Lambda functions and these SQS queues have a potential failure path for them. And so with Lambda, we have a concept called dead letter queues, which are essentially another SQS queue where failed invocations can go to. Once they go there, you're going to want to do something with them. So the first thing is you want to know if something's gone wrong. And so you would have an alarm watching the DL queue to say, hey, you're getting failed requests. We've captured them. You can do something else with it. And then you want to have what's called a redrive of that information. You want to essentially get it back into the flow of the system for whatever reason it was that it failed. And so we could then have another Lambda function that basically takes the request and pumps it back into the originating system. So we see up here that if I have a failure, I'm going to DLQ it, and I'll use Lambda to redrive it back into the originating queue. And it can basically do that for however long I want it to until it passes successfully. Similarly, down at the bottom here, if this queue fails to have this Lambda function process it, I can capture it. And if for some reason my transform function that's taking the data and changing the format, putting it back into S3 fails, I can do the same thing. Now what I have here are actually 3 of the exact pattern. So I've got 3 instances here of a DLQ, an alarm, and a Lambda function that's doing a redrive. Again, this is in one architecture, one component, 3 exact stamp outs of the exact same code, pretty much the exact same configuration, some slight variances that could be effectively parameters in a CloudFormation template. Not only that, but this top one up here, and technically the bottom one, represent entire repeatable patterns, right? Taking data asynchronously, put it into Elasticsearch. There's probably a lot of reasons and places that I'd want to do something like that. And so back in 2017, we announced the AWS Serverless Application Repository. This is part of the overall serverless family here at AWS. What it allows you to do is to publish and share full applications that are serverless. And so it's got pretty much, again, 2 operating models. One is that you want to publish your applications. You can do this both publicly and privately. The other is that you want to consume them. And again, you could do this publicly or privately. And so a couple basic actions, a couple basic places where you could do this. And then when you launch an app, it launches via CloudFormation in your account, and you get the code and the infrastructure and all the components that go with it. And so we can look again at this, where I've got these 3 repeatable patterns. These become 3 applications in SAR, or an app repo. In this case, these 2 are the exact same. They're redriving an SQSQ. This one is redriving a failure of a Lambda function. And then I can actually take this function right here, and back at reInvent 2018, just about 3 months ago, we announced something called nested applications. I can nest this application pattern inside of the top one and make this overall top one its own application too. That when I launch this application, it will include that application. So pretty cool. So I have this ability to do high-level reuse of code applications, becomes really flexible, and I could share this across my entire organization. So for all the teams that need to consume this, they can consume it in a safe and reliable way. So the API for App Repo is actually really straightforward. I think I counted earlier, there's 17 API calls today. This is what shows up in Boto, so it should be pretty accurate for what's possible. Again, pretty straightforward API in terms of what it is that you could do with it. And so Serverless App Repo is actually built using serverless technology. So it is more or less an example application for what you can do with serverless. The same kind of things you've heard everybody talking about here today. It's built with API Gateway and Lambda and Dynamo and S3 and kind of all the other good stuff that you would expect. And so basic flow here is that depending on if you are, say, searching in the console or you're using the CLI or SAM tools or any of the other SDKs, you start at Route 53. You end up at an API Gateway. API Gateway is using Lambda for both authentication as well as the business logic for that function. We've got a data tier where really the only thing that isn't serverless today is Elasticsearch. Excuse me. And then behind the scenes, we have a bunch of asynchronous processing to help glue all this stuff together, including some of what you saw that could basically take data from Dynamo and put it into Elasticsearch. And now there's a couple different levels to this. Really, each one of this SDK API represents, again, 17 different API functions. So that could be 17 total different Lambda functions tied off of that. Search, you could have a couple of different other Lambda functions doing stuff. It's more than one DynamoDB table, for example. It's more than one S3 bucket, and so on and so forth. But the basic kind of architectural pattern for serverless app repo outside of the console looks like this. And so what is not seen here? So I already talked about how some of the stuff in the asynchronous workflow, so things like SQS and SNS, that's not showing out there. There are some internal services that you don't interface with from a consumer standpoint, but that the team uses to manage the infrastructure and manage the data plane side. That's stuff that you don't see. You don't see development, so beta, gamma, and so forth. And you also don't see the fact that it's running in many, many regions around the globe. Again, that kind of cognitive overhead of the global operational workload. I spent a bunch of time talking to the development manager for this service, and I said, is everything really, really serverless? And we had the one example of Elasticsearch, and I said, is that really it? And the answer is, it's not. Unfortunately, they have to run some EC2 instances so they can test their serverless architecture. And so one best practice that we have at AWS is that you want to try not to create these effectively loops in your monitoring architecture, such that you wouldn't want a Lambda function testing that a Lambda function is doing the right thing. Because if Lambda goes down, you don't know that your stuff is broken because the thing that tells you your stuff is broken is broken. Makes some sense. So in this case, they're not doing anything high scale. It's basically like a single instance. it runs a bunch of tests against the API and tells you that things are good or not. So in building this and taking, again, our toolbox, what had to shift? What had to change? The answer is that not really much of anything, which is maybe the letdown of the talk here. But basically, what they were able to do is take things like CloudFormation and then SAM, and SAM's maybe the only new component as part of this, plug it into our existing CI and CD tools, plug it into all of the practices and things that we've done over time. They've got some differences in terms of how they look at things like telemetry, so observability essentially. So they're doing more logging, they're using tools like X-Ray, a couple of things that we have internally, but most of their practices don't change. And I spent quite a bit of time talking again with the development manager about this, and it's really standardized at Amazon. We're really heavy on peer reviews. Again, we're really heavy on CI and CD. We're firm believers that the only way to accurately test your applications is in the environments that they're going to run. And so Amazon developers do a lot of testing in the cloud, as it were, versus trying to mock an entire environment locally. We don't have the problem, the mythical problem of, I need to develop my apps from a plane. I always get this in the serverless space of, well, how do I develop my applications in a plane if I can't run the whole stack locally? Watch a movie, read a book. You're really not doing that much development on a plane. And given the confidentiality aspects of what we're building, our developers aren't writing code on a plane either. Go surprise. Things like linting, syntax checking, unit testing, all that stuff at the code level is exactly the same. Nothing about it has to change. A function block of code that exists in Node.js for Lambda is going to look exactly the same way as it would in a container or EC2 or something else. And so unit testing, service testing changes very, very little. We practice things like canary-based deploys, so deploy out to a small percentage of traffic in a region and then ramp up. And if anything goes wrong, immediately roll it back. It's one of the kind of basic rules that we have inside of serverless. And until Lambda supported traffic shifting in aliases, which happened in the fall of 2017, that was actually a big blocker for AWS and Amazon teams to consume Lambda, automated rollbacks. So now it's really trivial to do that with SAM, code deploy, and other things. So I really was trying to push on the development manager for App Repo, and I was like, okay, this is still sounding too straightforward. And so I used to represent the DevOps space at Amazon. I worked really closely with the tools, the builder tools team that builds our CI and CD tools and all that kind of stuff. And so I'm used to a lot of the standard pain points that our developers have. And I was like, there's got to be something a little more unique to me here. Can anyone think of what the #1 pain point was that the App Repo team ran into? Shout it out. Come on, you guys participate a little bit. Anything? IAM policies? The first one that she told me was actually limits. So they have the same kind of problems. So limits, scoping the size of a service. So where do you take an API for internal services and say this should be 2 services versus 1? Like where do you effectively think about breaking that up? Things like proper stack boundaries. So unfortunately, the 200 resource limit in CloudFormation is a limit for us the same as it's a limit for you. And so how do you think about breaking up CloudFormation stacks? And we talked a bit about how they're thinking about splitting up things like putting alarms in one stack, putting IAM resources, policies, et cetera, in another stack, and then putting the various application bits in their own independent stacks as well. And those are just general kind of patterns that you could look at doing depending on your size and scale. And then the last 2 I think are true for everyone, right? Alarms, monitoring, testing, those are all things that you never hit a finished state. Anyone who tells you that they have 100% code coverage has 100% bullshit in their testing. And so, or some percentage greater than 0. And so looking at these things, responding to incidents, failures, et cetera, and how to recover from them. And so again, AWS service teams are just like you. They're running into the same kind of issues, the same kind of troubles that we're hearing earlier when James talked about a bunch of the blockers that are now resolved. Those are the same blockers that we hear of internally. And so the good thing is that it's pretty even in terms of people's experience. Except, now again, I talked a bit about the history of how we do development in AWS. And this is probably the biggest differentiator for us versus for most of you. Again, we've been practicing microservices and small team-based development for well over a decade now. It's basically how developers are trained day 1 when they come into AWS is, hey, here's a decade plus of our best practices for doing stuff that just happens to align really, really well with serverless and functions as a service, and again, these really small base services. And so that's one place where I would say we have a really huge lead on most of the industry, is that we've just been acting in a way to make this be successful for long before the technology was there. Another thing is that we have that fixed box of tools that is a lot of standards, but is really flexible. And so I think that this is another opportunity for folks where they need to look at the tools they have internally, especially in larger organizations, and shrink those way down. We don't have half a dozen logging tools at Amazon. We have about 2 or 3. And so when I look and talk to, for example, enterprise customers, it's typically a one of each of the various solutions that are out there in the industry, and that's way too much spread. CI/CD is a must. This should be something that I shouldn't have to say in a talk in 2019. However, it's a thing that I have to say in a talk in 2019. And so working towards automation of your deployments is one of the most key things that you can have towards getting to a comfortable place to make rapid changes, to test new things, and to be able to be successful with this technology. Another thing that I like to call out is peer review. How many of you do code peer review as part of your deployment process? I don't believe that many of you do it that way. I don't believe it. That's not what I've seen. But making this a formal part of what happens for deployment, literally blocking deployment until a peer has signed off on something is pretty key as well. Another thing is that, again, we've been building REST APIs for a really long time, and we actually know where not to use REST APIs. One of the things that I've seen in the serverless space for the last 2 years is this thought that A, everything is functions, and that B, it's all driven by APIs. There's almost 50 different services at AWS that can invoke Lambda. Only one of them is API Gateway. Another one of them is ALB. But beyond that, you're not building API-based interfaces for a lot of workloads. And I would say there's one caveat to that is understanding sync versus asynchronous. Everyone thinks they need synchronous calls. I don't understand why, but they do. But really looking at asynchronous is really important. Again, think about that forked flow that I had. Everything past that first Lambda function was asynchronous, and we do a lot of asynchronous at AWS. A couple other things. If you're completely new to this space today, and this is all really new, and you're really early into your journey to doing serverless, if it feels like a really giant shift, it's probably because you're really far behind. And that's just kind of being frank. James talked about this earlier about, he made the analogy of there being kind of a 50-year gap between where some companies are, where other companies are. That's a really big gap. I think it's more like 10 to 15 years. But still, we see a lot of companies that haven't started thinking about microservices, haven't been thinking about REST APIs. And so when you start to do this, it's going to feel like a huge leap in how you mentally have to think about developing the software. The next is someone reached out to me just last week, and they said, hey, someone who actually is a consultant, their company builds serverless applications for our joint customers. And they said, I got this pushback from one of my customers. Give me your feedback on it. And the pushback was basically, we can't do serverless here because we would have to toss out our entire development stack. And I was like, wow, that's a drastic amount of things to have to replace. Again, in the case of what we've done internally at Amazon is it's the same code repos, the same CI and CD tools, the same testing tools. And when I look across the industry of what's available in those spaces, I really don't find the need for you to replace them for serverless applications. Really, the only thing that changes is how you deploy and then how you handle observability. Those are kind of the 2 biggest areas. So watch out for the folks that tell you you're going to have to change everything if you move to serverless. That everything is pretty dramatic, and they usually have some sort of ulterior motive. And then the last thing here, and you've heard this throughout today, is that the benefits are worth the time spent getting over the hurdles of the ramp up. We see this all the time. The last 2 years at reInvent, I've spoken with fairly large AWS customers. One was Capital One 2 years ago. This past year I spoke with Centrica, which is a UK utilities company. In both cases, traditional enterprise organizations making the shift to serverless, having to ramp up, having to learn the ins and outs of it, immediately finding benefits. Saved money, increased agility, reduced operational overhead. And so all of these things end up paying off over time. Well, given the title of the talk, this was all kind of boring. There wasn't any really huge gotcha. There wasn't kind of any sort of, diving saves. There wasn't any rip things out. And push people into dark corners and make them figure stuff out. Really what we find is as teams are moving from this traditional model that we have at Amazon to serverless, it's not a really big jump. And there's kind of this movement or this motion around boring tech. I've worked at a company called Etsy many years ago. We had a very boring stack. It was PHP, it was MySQL, it was Apache, it was Linux. It wasn't a lot of exciting things. And I think when we talk about the serverless space and where we are kind of 4 years after the start of it, for a lot of organizations, we're approaching the boring space. I think is Ben still in the room? I'm not sure if Ben is here, but I think he might agree that at iRobot, serverless has started to become boring in the sense that it's standard, it's safe, it's trusted, they know how to operate it. And so I think we're going to start to see this as the years roll by here, maybe the next year or so, where companies will start to say, yeah, it's no-brainer. We use serverless, it works, everything's good. We've gone over the rough edges and so forth. And again, this is kind of the idea, and it could lead to a really exciting future. And so if I go back to the story of Amazon and two pizza teams and microservices and all of that, as we shift that burden from, again, the green circle to the blue circle and using platform services and using managed tools and kind of reducing the decisions that the teams have, we find that you're taking a lot of work off of those developers' minds. They all of a sudden have a lot more free time. They're moving a lot faster than they used to. They're getting through the development roadmaps a lot faster than they used to. And so when we look at a business, at what it takes for us to spin up new services, to spin up new ideas, to experiment, we get to start to ask ourselves, is two pizzas one too many? And when I've talked to a lot of customers that are moving towards serverless as well, what they find is that they're doing more with less. And when you're doing more with less, you get to do more with your existing group of people. And so, again, going back to the analogy or the story before of 60 million deployments, when we look forward here, say by 2020, and we've got teams that are doing serverless deployments, and they're doing many regions, and it's automated, and they have a lot less operational workload to think about, and a lot less kind of cognitive load of all the decisions or things that they used to have to manage, what is the number that will hit? So lots of opportunity out there, lots of things to think about. This was an awesome first serverless days for this community. We're seeing massive growth of these events around the world right now. The first serverless days happened in July of 2017. Here we are, just about 18 or so months later. There are going to be about 30 serverless days around the globe this year. And so, again, you're going to see and hear a lot more of these stories. My name is Chris Munns. I am the lead developer advocate for serverless at AWS based out of New York City. Been with Amazon, again, for just about 7 years. I'll be out in the hallway at our booth. I think you've gone through all of our stickers, but we might have some more left. You can find out a lot about serverless at aws.amazon.com/serverless. And I'm always available. You can find me at munns@amazon.com. You can harass me at Chris Munns on Twitter, and I'll harass you back. So thank you.